What if everything you learned about mass increasing with speed is wrong? Not just outdated, flat out misleading. You've probably heard it. As things go faster, they gain mass. But here's the twist. Though often attributed to Einstein, the idea of relativistic mass was introduced by others, exposing a common myth in physics today. Why? Quantum theory shows that mass defines a particle's identity, while energy varies with motion, a view Einstein eventually recognized and supported. He understood that defining mass as speed-dependent led to conceptual errors, especially in the context of quantum theory, where particle identity must remain fixed, as fixed quantized properties define quantum particles. If mass truly changed with speed, then fundamental particles would no longer be identical. Yet that never happens in any experiment. Take the electron in an atom. When it jumps between energy levels, its speed and total energy change, but its mass stays exactly the same. The spectrum it emits or absorbs depends on fixed energy gaps, not shifting masses. Even inside protons, where quarks move at relativistic speeds, the proton's mass remains fixed. It doesn't come from the motion of its parts, but from quantum field energy and binding interactions. The same is true for the muon in particle accelerators. As it approaches near light speeds, its kinetic energy rises dramatically, but its rest mass never changes. All its interactions depend on that fixed value. And here's a core principle of quantum mechanics. All particles of the same type are entirely identical. For example, every electron in the universe has the same mass, the same charge, and the same spin, no exceptions. This identity isn't just a feature, it's a rule. If relativistic mass were real, a fast electron and a slow one would have different masses. That would violate the principle of indistinguishability. And if particles aren't identical, quantum mechanics, which depends on indistinguishable particles, would break down. So why does the myth of relativistic mass still survive? Because it feels like common sense, and early relativity textbooks leaned on it, before quantum theory clarified the deeper structure. But nature doesn't follow common sense. It follows mathematical precision. Want to describe a rocket? Torque energy. Want to understand an electron? Forget mass increasing with speed. That's a leftover from an era before quantum principles reshaped our view of particles. It's time we let go of relativistic mass, not only because it's wrong, but also because it hides the more profound truth. Mass defines identity. Energy expresses behavior.